Welcome to part 1 of our step-by-step tutorial on how to check modal mass participation in ETABS in strict compliance with Codal provisions. Before we begin, ensure that your structural model is fully defined, all dead, live and lateral loads are properly assigned, and your mass source is correctly configured. For a clearer view of the structural response, let's switch over to the first floor plan view so we can easily monitor our building layout during the evaluation. Now let's proceed to evaluate the dynamic behavior. Navigate to the top menu bar or the toolbar and click on the Run Analysis button. ETABS will now begin processing the stiffness matrix, evaluating structural displacements, and executing the eigenvalue or Ritz vector analysis to determine the natural frequencies and mode shapes. Let's wait a few moments for the software to complete the calculations. Once the analysis finishes successfully, we need to extract the structural output data. Go up to the top menu, click on Display and then select Show Tables from the drop-down menu. In the interactive Choose Tables window that pops up, navigate through the tree structure. Expand the Analysis Results branch, then expand Structure Output, and look under the Modal Results folder. Check the box labeled Modal Participating Mass Ratios. Click OK to open the comprehensive data table. With the table open on your screen, you can carefully review the initial time periods, frequencies, and mass participation factors for each individual mode shape. Take a close look at the initial modes. If you notice that the building is experiencing significant torsional twisting early on, or if the structural mass is failing to accelerate effectively in your primary orthogonal directions, it indicates a structural imbalance or lack of lateral stiffness. To fix this, we need to unlock the structural model by clicking the padlock icon and confirm the action by clicking OK so we can make these mandatory design modifications. Next, carefully select the specific frame elements or columns that require optimization to increase lateral stiffness. Once selected, navigate to the Assign menu, select Frame, and then click on Local Axes. In the Assignment dialog box, let's rotate the local axis by 90 degrees. This change will reorient the columns, shifting their major axis of bending to enhance structural stiffness in the weaker direction. Click Apply, and then click OK to close the window. Now that the column orientations have been updated, we must re-evaluate the building's dynamic performance. Go ahead and click Run Analysis once again. After the calculation wraps up, return to the Display menu, open Show Tables, and bring up the updated Modal Participating Mass Ratios table to analyze the new results. To make this data easier to document, sort, and evaluate for your final design reports, right-click anywhere inside the data table and select Export to Excel. Once the data populates in Excel, let's quickly clean up and format the spreadsheet for a clearer presentation. Highlight the column headers for UX and UY, which represent the mass participation factors in the X and Y directions, and change their cell formatting to percentage. According to standard Codal provisions, the cumulative modal mass participation must reach a minimum of 90% in both of the principal orthogonal directions. Scan down the sum UX and sum UI columns to verify that your structural model successfully crosses this 90% threshold. Finally, we need to verify the criteria for closely spaced modes. As per the governing Codal provisions, we must evaluate the relative time period difference between consecutive modes, specifically examining the relationship between the second mode and the third mode. If the percentage difference between their consecutive time periods is less than 10%, these modes are classified as closely spaced. When this occurs, standard Codal guidelines dictate that an advanced modal combination method, such as the complete quadratic combination or CQC method, must be utilized for your response spectrum analysis instead of the square root of sum of squares or SRSS method. Let's type out this exact compliance check directly into our spreadsheet to complete our Part 1 structural assessment.